This is 2.5 transformations. We just got done learning 2.4 and some of the common parent functions. And now what we're going to learn is how to transform them. Again, make sure you know how to do parent functions of the common functions that we did. So you might want to relook at those, make sure that you're familiar. Again, here's a look at our last lesson. Again, these are not all of the parent functions. These are just some of the common ones that you guys have seen before, and you've seen them multiple times. And so just become very familiar with these parent functions. All right, and what we're going to do is transform them. So let's learn how to do the transformations. And you have done this before in prior classes, but we're going to emphasize it here. And you don't need a calculator to do transformations. All right, so if I have y equals f of x, that's my parent function. And then if I have a number on the outside, like plus 4, plus 3, minus 9, minus 6, a number on the outside, it's going to literally shift up or down, do a vertical shift up or down based off of the parent function. So again, the parent function may be y equals x squared, and then if I ask you to graph x squared plus 4, well, notice it's the same function, it's just 4 spaces higher. It's the same exact function, except 4 spaces higher. So it's the same parabola, you just shift it up 4 spaces. So again, if you look back at your parent functions, here's x squared, you just shift it up 4 spaces. And shift this point up 4 spaces. Shift this point up 4 spaces. So the parabola will look like that. So you don't need a calculator. If you know the parent function, then you just shift it up or down. Or this next one, if I have a number with inside the parenthesis, you're going to shift it left or right. You're going to do a horizontal shift, left or right, and it's always the opposite direction. So the number on the inside shifts it left or right, the opposite direction. So again, if I had x minus 2 squared plus 3, well, this shifts it up 3. This shifts it, again, since it's subtract 2, we're actually going to go 2 spaces to the right. It's always the opposite direction. So again, you would take that transformation, you would go 2 spaces to the right, and then so many spaces, I've got how many spaces I said, so up 3. So you would take it up 3 spaces, and then 2 to the right, and then here, and then here, and then you would graph it. Okay, so you would just translate it or transform each one of these to the up or down, and then to the left or to the right. Now, if you have a number, negative sign on the outside, it reflects it, so it literally flips it. And you guys should already know this. If it's negative x squared, it's going to be a parabola going down. So it just reflects it. So the vertical, there's also, if you have a number on the outside, it stretches it. So again, think of the parabola, y equals 2x squared. So it literally is being multiplied by 2. So it stretches it or grows twice as fast. So it literally, instead of a normal x squared, it would be thinner. And let me switch colors. It would literally grow quicker. It would be a thinner parabola. Right? And it doesn't have to be a parabola. It could be any of the functions, okay? But the number outside, if it's bigger than 1, it stretches it. So think of a rubber band. When you're pulling on a rubber band, it makes it thinner, okay? And if it's, bigger than 1, so you're stretching it by a factor of 2 or 3 or 4, then it's going to make it thinner, thinner, thinner. If this happens to be in between 0 and 1, like 1/2 x squared, then it's going to be a wider parabola. 1/3 is going to even be a wider parabola. 1/10 will be a very wide parabola. So, it shrinks it or makes it wider if you want to look at it that way. All right, so let's look at some of these functions, and I want you to be able to graph this without the calculator. So think of the x cubed function. So if you go back and think of the x cubed function, it's going to look like this. And notice all I'm doing is I'm going to, the number on the outside is going to raise it 1 spot or 1 space. All right, so you're literally going to take each of these points. You're going to take that point, but you're going to raise it 1 spot. Take this point and you're going to raise it 1 spot. Take this point and raise it 1 spot. and then down here. So it's going to look like this. It's the same function. I just raised it one position. This one right here, you're going to raise it one. And this is going 2 to the left. Remember, the inside number is the opposite direction. So again, if you know the parent function, x cubed, and that's what this is. See, it's still x cubed. See, x cubed? It's still x cubed. But you're literally going to take it. Let me erase this. So it's still x cubed, but you're literally going to look at this, and you're going to take 2 to the left and then raise 1. So look at this point, and 2 to the left, raise 1. Look at this point, 2 to the left, raise 1. And then each one of these, 2 to the left, raise 1. So each one of those is going to look like this. You just shifted the function. Again, I don't need a calculator. Now, by the way, if you, even without a calculator and you're getting confused on this shifting, what you could always do is make an XY chart if you wanted to. You don't have to. This obviously takes more time. But if you plugged a 0 in, if you plugged a 1 in, if you plugged a 2 in, or -1, and then you could literally plug it into that function and evaluate it. But it's so much easier to learn the transformations to be able to do that. All right, so here, again, we have a x squared. So this is a parabola. And notice it's 2 spaces up. It's 3 to the left. And notice that negative is going to reflect it. All right? So this is reflected. So if I ask you to describe this, these are the key words that I would be looking for. And then think of the normal parabola. The normal parabola that you would, this is the normal parabola, the parent function. So that's just y equals x squared. So if we take each spot and we go 2 up, so I'm going to go 2 up and I'm going to go 3 to the left. So let's take this first point. I'm going to go 2 up and 3 to the left. So that's what this point is. And I'm going to go each one of those, and I'm going to do the exact same thing, and I'm going to start to reflect it. Okay? I'm going to reflect it. And you want to go in that order, by the way. Do the reflection last. So again, we took that point, we went 3 to the left and then 2 up, and then we're going to take every point and we're going to do the exact same thing, and notice it's being reflected. So if I go this space right here, let's do this point right here. If I go 2 up and 3 to the left, it's right here, but I'm going to reflect it. And then the same thing, go 2 up, and then 3 to the left, and I'm going to this point right here. Sorry, go 2 up and 3 to the left, but then I'm going to reflect it. So it's going to go here. And each one of these, you're going to literally reflect it, and be able to get even this one right here. Even this one right here. You're going to go 2 up, 3 left, and then you're going to reflect it. Each one of those. All right, so again, I did every single one of those points. I did 2 up, 3 left, and then I reflected it, and then be able to draw your parabola so it's still the same shape to be able to do that. All right, so what we're going to do next, so notice this is a parabola again. So here we have 1 down. This is 4 to the right. And this is a growth factor of 2. So growth of 2, or you want to call it, some books or websites call this a growth factor, or some call it a stretch by a factor of 2. So either way, so we'll say growth or stretch times 2. So everything's being stretched 2 times. So this parabola is going to be a thinner parabola. Okay, so it's going to be thinner. Again, think of a rubber band. If you stretch the rubber band, it makes the shape of it look thinner. So again, you're going to take the same parabola, the same parent function. So if it helps you to draw the same parent function, That's the parent function right there. And then what we're going to do is shift everything 1 down, 4 to the right. So I always start at the vertex. So 1 down, and then 4 to the right. Everything's being shifted in that direction. So, but it's going to be, notice it's going to be stretched by a factor of 2. So notice what I did is, like normally once you find your vertex, it's growing twice as much. So normally this goes over 1, then up 2. So notice it's going over 1. I mean, it normally goes up 1, over up 1, over 1, up 1. And then I did over 1, up 2. This one goes over 1, up 1, 2, 3. So I literally went over 1 and then 1, 2, 3, 4, 5, 6. Okay, because again, it's growing, stretching twice. So it's growing twice as fast as the other one. Again, that's growth, stretch, shifting it, transformations. It's all of those right there. And again, I want you to